Hello everybody, welcome to our video solutions to Superquiz 3. It's from the fall 2021 semester Math 106, which is our integral calculus and differential equations class. So this Superquiz is all about sequences and series, their convergence properties, etc. And this very first problem, we're given a sequence and we're asked to show that it converges to 0 using the definition. Okay, so that is the definition of sequence convergence. So before we jump into the sequence, let's just quickly recall what that definition is. So a sequence A of real numbers, and of course this problem is about real numbers, converges to the real number L if every L coin, so remember this is really an acronym for an L-centered open interval, right? So the C is for centered, O for open, IN for interval. So we're looking at, I take some L, and then I go a little bit to the left, say epsilon, and a little bit to the right, say another epsilon. So this is an open interval. It's open because it has the parentheses on the side, which means we do not include the endpoints. All right, and it's centered at L because L's right down the middle of it. Okay, and this would be an L coin, we would say, with radius epsilon. In any case, the claim is that a sequence converges if every L coin contains a tail of A. All right, so remember if I have some sequence A and it looks like, I don't know, maybe we'll start it at 1, A1, A2, A3, and so forth. I can start my sequence at some point, like, I don't know, A8. Okay, and I just say, okay, let's start it at 8. And this is what we would call a tail of the sequence A, because you're basically cutting off the head, right? You cut off, in this case, the first 7 terms. Okay, and to contain a tail means you need every term in the tail, which just means, right, if you started plotting A on the line, you should get something that looks like, okay, maybe there's my A1, my A2, my A3, but eventually, right, maybe all of these points get really, really close to something, and oh, now they start turning around and coming back. Okay, who knows? Okay, but for this L coin to contain a tail, all of the points in A, right, once you get past, whatever that is, A8, whatever, all have to lie inside this L coin, okay? And of course, remember the reason why we called an L coin, besides it being an acronym, is right, we have this great visualization of an actual coin, right, lying on top of this. Okay, so we would like to prove for this particular sequence, 1 over n to the k, where k is some positive integer, right? K is some fixed number, n is varying from 1 to infinity. We want to show that this converges to 0, which intuitively should be very clear. As n goes to infinity, n to the k goes to infinity, 1 over n to the k should be going to 0, right? But how do we actually prove that? I mean, it seems reasonable, but how do we prove it? So we're going to use the definition because, well, that's what it tells us to do. Okay, so let's let epsilon be some number greater than 0. Okay, that's going to be the radius for an L coin. Because, again, to prove that the sequence 1 over n to the k converges to 0, we need to, by the definition, show that every, well, what's our L here? It's 0, right? Because that's what it's converging to. Every 0 coin needs to contain a tail. And a 0 coin is going to have some radius. Okay, let's call that radius epsilon. Okay, so this epsilon is the radius of a 0 coin. Okay, so we can even draw our picture. There's 0. We can put 0 minus epsilon on the left, 0 plus epsilon on the right. Of course, 0 minus epsilon equals negative epsilon. 0 plus epsilon equals epsilon. Okay? So we need to show that we can find a tail, right? A tail of the sequence. So we need to find a tail of A contained in the zero coin with radius epsilon. Okay, so what does it mean to find a tail? Well, we need to figure out what this number is, right? How far out do we need to go, right? So i.e. find n, okay, we'll use a capital N here, such that if you go anywhere past that n, right? So A8, A9, A10, etc., then A sub n, which is equal to 1 over n to the k, is contained in this zero coin. Okay, well, what does it mean to be contained in the zero coin? It means you're some element in this set somewhere between negative epsilon and epsilon. So you're contained in this open interval centered at 0, negative epsilon to epsilon. Okay, we can make a nice observation, though, that'll simplify this a little bit. If we look at 1 over n to the k, all right, 1 over n to the k, n is going to be positive, k is positive, 1 over n to the k is positive. Like, all this stuff is positive. So even though in principle we need to show that it's contained between negative epsilon and epsilon, we know that it's not ever going to be negative. So we actually need to find all the points over here on the right. So this is equivalent to showing that it's contained in 0 to epsilon. Okay. Now, when would 1 over n to the k be contained in here? Well, it means it has to be greater than 0. Okay, that's true for sure, right? Like, we know this is positive. Okay, but it also has to be less than epsilon. So this is what we need to make happen, right? This is the important bit. All right, well, let's invert everything. So this happens if and only if. Okay, and I'm just going to, again, I'm going to ignore this thing being positive because we know that's true, right? So this is true. So if I invert things, I have n to the k, and I get 1 over epsilon. But when you invert, inequalities reverse. So instead of less than, I'll get a greater than. Okay, so when is n to the k greater than 1 over epsilon? Well, we're going to take an nth root. So here we inverted. Now we're going to take a kth root, rather. And when I take the kth root of n to the k, I get n. And then over here, I get the kth root of 1 over epsilon. So this tells me that if I want 1 over n to the k to be less than epsilon, then I need my n to be at least as big as the kth root of 1 over epsilon. And so we set big N equal, or we'll just say to any positive integer greater than the kth root of 1 over epsilon. Because as soon as n is greater than this number, then any little n greater than or equal to n will also be bigger than this number. Okay, so if we do that, then, so for all n greater than or equal to n, a sub n is in negative epsilon to epsilon, even 0 to epsilon. And hence, the tail, a sub big N, is contained in the 0 coin with radius epsilon. Okay, and so this proves, thus, the sequence A bar, didn't want to erase, there we go, A bar converges to 0. And that's our proof. All right. Yeah, it's a little challenging, right? It's definitely more than just your intuition going on here, right? But if we want to prove things, sometimes we have to get down into the nitty-gritty, and it really helps to have a definition that lets us do that.